Well, good afternoon, everybody. Welcome to the EUA and IGEM Gas Industry Awards 2021. Moved on from 2020, you would have noticed. This is the Innovation Awards webinar. I'm Dennis Kirby from SGN, and just to let everyone know, we are recording this session. Now, we're going to hear from 3 shortlisted candidates for the Innovation Awards webinar very shortly, from Baxi, Cadent, and Morrison. That's in alphabetical order. If you're thinking there's any clues in what order they're going, there isn't. We don't know the winners. They don't know the winners. So it's all to play for, as it were. So we're going to be very excited to hear from all of them. What we're going to get is a presentation for 10 minutes. Then there'll be a Q&A option. And here you can ask your questions. You can post under the stage section within this portal. So hunt that down. If you think of a question you want to ask, get that typed into stage, and we'll ask it to each candidate straight after their presentation, just to keep it relevant. Now, I've been thinking about my favorite innovations, as you do in times like this with the Innovation Awards coming up. And I actually went right back in time to the Concorde when it got put out in 1969, it came about. And I remember there was one innovation that caused me a bit of a problem. It got me a school detention once in 1976. I was sitting in the maths class watching the first commercial flight go past, and then suddenly that was it. I was in trouble for not paying attention. So good old Concorde. But it's interesting, it came out at the same time as the old 747 back in '69, but very different lifespans, very different applications, both of them. One of them, that glamorous life in the fast lane that never really took off because of a few flaws, noise, fuel consumption, maximum 100 passengers. And you got the 747, which did what it meant to do. Over 1,500 of them built, 460 passengers each time. And it just showed, for me, just thinking about that, you know, the innovation in today's world, it just needs that practical edge. It doesn't have to be sexy, but it does have to have an end use, benefits the maximum number of people that it can be to really be successful. So we're going to hear about some gas industry equivalents of the 747 and the Concorde, perhaps, in terms of those innovations, those thought processes that people have gone through, and the fantastic achievements that we're getting out of it as well. So without any more ado, I'm going to introduce to you our first speaker. He's Jeff House, who's going to be on screen any minute. He might be there now, I can't see. But Jeff is from Baxi Heating, and he comes to us with a wealth of technical, commercial, and legislative knowledge gained over the 20+ years in the building services sector. His current role, he's focusing on getting the political and legal agenda right for the UK heating sector, really important for our futures. And representing Baxi in the wider industry, he's been talking to government and many trade bodies. So, well, without any more ado, I'd like to pass you over to Jeff.
Thank you, Dennis. Thanks for a great introduction there. So I've got some slides here to support the 10 minutes section here. So I'll quickly share my screen. So that should be there. Good afternoon, everybody. My name is Jeff House. I'm Head of External Affairs here at Baxi Heating, and we're part of BDR Thermeo Group as a global entity. So our award entry is essentially all about our work around pure hydrogen boilers. So we've, as a group, been spending a number of years now looking into the idea of pure hydrogen as a means to decarbonise, you know, a vast swathe of our current heating use. We've made some great strides, and with help from the BAES and Heat Consortium, there's been some great work here in the UK, which we'd like to talk about. So, why hydrogen? Well, homes and a fairly vast chunk of our businesses currently use gas-fired boilers and equivalent sort of technologies today. So if we're going to tackle decarbonisation seriously, there needs to be a viable option for, you know, some of those buildings that are going to be harder to treat, and also something that's going to be fairly low disruption that will be consumer friendly. So that was really our starting point. So we took a current natural gas platform, so picture on the left there of a, you know, representative one of our boilers, that's in, you know, millions of homes. It's perhaps not love, but it's certainly known and familiar, and it's something that people are used to. So the idea was, try to make something or develop something that is as near as possible in terms of size, weight, efficiency and performance to the current appliance, thereby getting around some of the issues that you're going to see for other options that are out there. So these things are going to be replacing boilers that are in people's kitchens, in kitchen cupboards, in other tight places. So size is pretty important. Performance, so if we're going to get around this idea of having people accept change, then try to make it something similar to what they currently have. We'll perhaps get over some of that, and obviously efficiency and all that good stuff is all part of it. In and of itself, it looks very much like a boiler. We were talking before about Concords, and really sort of high flying and fancy innovation. As far as innovation goes, it's supremely innovative, but at the same time, it's also relatively boring. It looks like a boiler, but that is. So, from a technical point of view, a number of things we've really had to consider and spend a lot of time on in the lab and now in the field. So, for those that are more aware of this stuff, hydrogen combusts differently to natural gas, so there are some technical challenges to overcome. So first and by no means least is hydrogen flame speed. So when you actually spark the input gas, the actual speed at which that flame will spread across the burner surface is significantly faster. So you have to control that flame. It also tends to sit a little bit lower on the burner face of the appliance. So again, there's a potential there for what we call flashbacks. So you need to have methodology and design around prevention and mitigation of that. Control of the flame, absolutely critical stuff. And safety is first and foremost in everything that we do. So clearly, this is something we wanted to get absolutely spot on from the get-go. And flame detection. Again, one for more of the engineer crowd in the room. When we currently have natural gas fired appliances, there's carbon in the fuel. Therefore, we can pass an ionisation current across that flame, get some reaction there with the carbon, and then you can prove a flame. That's not possible with hydrogen because there's no carbon there, so we've had to look at a number of different flame detection methodologies there. So we've got a mix of things happening there. Also, material compatibility. So there's a bit of discussion around hydrogen embrittlement, especially in an effect on materials. So the sort of pressures that we're dealing with behind the meter in a domestic setting, especially we're down at 20 millibar, that's not necessarily a particular problem, and it's something we understand that is more prevalent at higher pressures. However, pretty much everything that is facing hydrogen inside the appliance has had a full review, and there's been some material changes as a result of that. So where we've ended up is a boiler that looks the same and performs the same as one of our current natural gas boilers, but runs on hydrogen. So the carbon thing is solved, which is the absolute sort of key intent here. So we've got a nice picture here of one of our lovely design engineers. That's John Harkins up at our Preston R&D facility there, doing a bit of a shot with the boiler. And really pleased to say that it's to the same size, it's comparable weight, so lift weight's not an issue, and that performance is there. So the efficiency is comparable to that of our current condensing boilers. One thing we're asked a lot about of late is NOx. So there's a bit of a misnomer sort of doing the rounds that burning hydrogen will automatically lead to a higher prevalence of oxides in the combustion. When we look at the appliances that we've developed, that's absolutely not the case. So we have to look at the mix of air and fuel going into the supply and doing some smart things around the control of that in order to deal with things like flame control. Almost as a byproduct, has resulted in really low NOx emission. It's actually lower than our current best condensing boiler, so really good output there. Again, almost a secondary benefit, we've found that because there's no carbon in the fuel, so the first sort of priority is all about net zero and climate change, but because there's no carbon, there's no production, no possibility for production of carbon monoxide. So although a really secondary benefit, it is a positive safety benefit nonetheless. Hydrogen ready is something we'll come on to in a second, but hydrogen ready, we believe, will be a really good stepping stone and enabling step for a big chunk of the housing stock. And we're in a position now where we've effectively got a good prototype out in the field. We've got some run hours on it, and we're really ready to start commercialization or pilot project demand. So there are some larger scale projects in the offing, which you'll have seen in the press. So things like H100, for example, with SGN, another project in the mix. So hydrogen ready then. Again, is something that's probably a really, really important point this year. I'm expecting to see some kind of consultation from government on the potential role for hydrogen ready appliances. So if we look at today's natural gas boiler, because of the work that's happened at HyDeploy, we're fully confident that our natural gas products can operate on a 20% blend by volume of hydrogen, and that's something that's proven anyway as part of the current certification program. So that's a given. 20%, can happen quite happily from a technical point of view behind the meter. So the idea is with a hydrogen ready boiler is a boiler that works on natural gas out of the box. Therefore, it can work on up to 20% hydrogen out of the box as well. But some of the internal componentry is ready to be converted to hydrogen in the future, or is future-proof. Can be installed by the current operative skill set. So that's going to be, today's gas safe registered engineers. So then at the point of a conversion to pure hydrogen, so be it a given city or regional area, so for example, Leeds is one that comes up quite often. It's going to be the case there'll be a mix of products there. So there might be some that are, legacy gas products that would have to be replaced. So we've got a pure hydrogen boiler ready for that. It could be the case that a hydrogen ready boiler has been installed, in which case we've got a really simple and easy low impact conversion process. So it literally is less than an hour, change of a couple of small parts, recommission the boiler, and off it goes. So we really think that for the 1.6 million plus gas boilers that are sold in the UK each year, if there's a mandate there to have those hydrogen ready by a certain date, we can really pre-populate a big chunk of the housing stock and make a big inroad towards a future conversion in terms of making it more readily addressable. So just to finish up, I talked about demonstration sites. We very much are in this process now of moving from the lab to the field, is what we like to say. So in the UK, through Hy-Vee, we've got the high street installation at Spade and Cumbria with DMV and partners there. So that's the bottom right-hand picture. So we've got a combination boiler there, which has been working away since late last year. In the left-hand centre picture, we've got an installation that's happening as we speak. So Low Thornley Gateshead, the hydrogen home. So again, that's going to be a pure hydrogen demonstration that will be open to stakeholders to look at later in the year. And then across, different market footprints where we operate as BDI Thermo Group. So we've got what's believed to be the world's first live installation of a domestic hydrogen boiler in Rosenberg. That's been a great success. Nice little project in Outhorn where we've got a partnership with a local housing association. So there's a dozen homes there unoccupied that have been fitted out with full hydrogen appliances and looking at safety testing and all of the performance stuff you'd expect there. Appledorn, near our group HQ, there's a training centre that we've done in partnership with Kiwa, which is opening fairly shortly. Then last but not least, this is one I really like, at Bassano. So we've got an R&D and production facility in Bassano. Everything we make for the UK market is done in Preston. In Bassano, we work in collaboration. So the bottom left and top left pictures there, we've got over 1 megawatt of PV feeding an electrolysis plant on site there. So we actually generate our own green hydrogen for testing and demonstration purposes. So it's a really nice sort of end-to-end demonstration of the whole hydrogen sort of value chain there. So that's the bit really. So essentially a great deal of innovation in a relatively boring looking boiler box, as you can see on the top right there, but importantly, low disruption and very practical from a consumer acceptance point of view. So at that point, I will stop sharing. Thanks for your attention, and we'll hopefully have a few questions to go at.
That's fantastic. Thank you so much. If we do have any questions, please type them into the stage set on the on your application there. I've got the first question, if I could just throw in there, Jeff. been as a company very interested in hydrogen as well, and making sure this all works out well. What about the field trials? What been the findings so far from your field trials? What have you learned?
Well, thank you, Dennis. Yeah, it's been a really, really positive process, to be honest. We've not had any significant problems to date. So, as I said, we've had the one in Rosenberg running for a couple of years now. Some of the UK ones are, have been running for a few months. We've got a good log of run hours, and all of the appliances we're putting in are what we call connected. So we do remote diagnostics and remote monitoring as well, so we can actually see number of starts and performance criteria. And yeah, all very positive to date, and we're really enthusiastic.
Thanks for that. And how are you finding the Netherlands government approval of this? Is it an easier path to tread than the UK government, or is it equally difficult?
It's an interesting one, really. So I have colleagues at Group that cover the respective countries, so I'm not a specialist in the Netherlands aspect at all, but obviously we talk. There's been some really interesting developments there, because you had some of the issues around the Groningen gas fields, and that led to a little bit of a policy have gas in homes, and should we start to look towards electrification more widely. Now that hydrogen's come along, and there's obviously a really good access there to a lot of wind power off the Dutch or the Netherlands coast, there's a real change of heart there, and we're seeing a lot of interest. So a great number of government related trials, as well as significant interest, which is again really positive. So I think we'll need, our mantra really is that there's going to be a whole host of solutions that we need to meet 2050, and artificially shutting any of those off at this point is, doesn't really make sense. So it's great to see that sort of options coming back around.
That's good. And there's a question here for Jeff, if maybe we could finish on this, unless there's anything else anyone wants to ask. But how do you see the process of upskilling the engineers that needed to ensure this hydrogen rollout goes well? Is it similar to like the smart meters that we had, or is this a very different process in terms of hydrogen boilers and installation?
Yeah, just got a little bit of break. We missed the end of that question, but I'll get the gist of it. So from our point of view, we're really obviously interested behind the meter and the installation of appliances and the looking after and maintenance of appliances. So the way we see it working, which it's work that's happening around industry at the moment, is potentially an additional module that installers and operatives could look to take. So, for example, if you have core gas safe competence today, then you want to work on LPG, for example, there's a module that comes in that would cover that, the additional skill set that would be needed for that. So we think, that a similar principle could readily be applied. But the general thing is, if you have a hydrogen ready boiler, there's no need to be any further skilled than you are today. You can fit one as and when it's available, and the skill set thing comes in when we start to look at conversion.
And final question: is it safe? Oh, can you hear me, Jeff?
Just got you back, yeah.
Yeah, just final question: is it safe?
All of the work we've done to date would suggest that the safety case is comparable to that of natural gas. So obviously there's work to go. Yeah, there's the safety case for the HSE from all the projects to come forward. But from our work, it's a flammable gas that we burn in a controlled way in an appliance, and it's engineered to accept and accommodate it.
Fantastic. Thank you very much indeed. I'd ask everyone to give you a round of applause, but that doesn't really work very well online, I'm afraid. So if you can imagine a virtual round of applause, thank you very much for your time.
No, thank you. And thanks everyone for your time and attention.
Lovely. Well, thank you. Now I'd like to move on to our second presentation of the afternoon. And this is Andy Lewis, who's the Future Networks Manager at Cadent. He leads, what Andy does, he leads the Future Roller Gas Innovation Project, the whole portfolio for Cadent. He's responsible for initiation, delivery, and subsequent deployment of the projects to explore how gas can contribute to a low carbon future, what it's all about, a low carbon future. In Andy's little CV that I got, it mentions Cadent is the UK's largest distribution network. That's always difficult for someone from SGN, who's the UK's second largest distribution network. I like to think of us as the third smallest, so it works always, doesn't it? So without any more ado, can I introduce Andy Lewis? Hope you're there, Andy.
Yeah, thanks. Can you hear me and see me?
Loud and clear. Yeah, go ahead.
Okay, perfect. Okay, all right, thanks very much. So I'm going to talk today about HyDeploy. I guess my background in HyDeploy is I initiated it back in 2016, which doesn't seem very long ago at all. And we've just completed the first trial at Keele University. So I've probably got more slides than time. So I'll skip through them quite quickly, and clearly we can come back to any questions you may have at the end. So just to start, so the consortium partners, so are Cadent, so we're the lead network. We've partnered with Northern Gas, Progressive Energy, who provided some project management for us, IGEM Power, who are electrolyzer SME, the HSE, predominantly on the safety case, and then Keele University, which is the host site. So hydrogen blends. So why are we doing all this work on hydrogen blends, basically? So we see it as a good first step. You know, we acknowledge that hydrogen blends in itself isn't going to get you to net zero. You know, we need to go beyond that. But it is important because it's something that can be done very quickly. And I heard Jeff mention that his boilers can deal with 20% hydrogen, not a problem. So it does develop that hydrogen supply chain, particularly with regards to hydrogen production, if we can put a hydrogen blend into all our networks. The carbon savings are the equivalent of taking 2.5 million cars off the road. So although we say blends don't have a huge decarbonisation value, you know, it still takes 2.5 million cars off the road, and that shouldn't be underestimated. And then I think importantly, it creates a roadmap for deeper savings to come in the near future. So the next slide. So I'd say the success of the first project at Keele University is definitely been the approval of the safety case, and that was basically no mean feat. So we had to go through a whole host of look at a whole host of different areas, assimilate the information and present that to the HSE to get sign off, and that was appliances, materials, gas characteristics, gas detection, and then also some stuff on customer perception. And that went from laboratory work all the way through to, you know, conducting the field trial. So we were awarded the safety case exemption back in, I'm trying to think when it was now, back in the end of 2018, which basically allowed us to start the build at the Keele site at the start of 2019. And what we built at site, you can see here from this aerial view. So we had the hydrogen production was predicated on a PEM ITM electrolyzer. We had power supply unit, we had some transformers, the first hydrogen grid entry unit, which basically takes the hydrogen from the electrolyzer, mixes it with the natural gas, and then injects it into the network. And then also a buffer tank, which acts as a mini store basically within the hydrogen compound. And this equipment now is going to remain at Keele University. So there's been a lot of sort of interest in subsequent hydrogen projects. We're also looking to use this facility in the future when we come to training all our gas operatives on hydrogen. So yeah, this is staying at Keele. Okay, so I guess just to give you a bit of background on the actual network at Keele, we've been injecting into a medium pressure network that then goes through pressure reduction into the low pressure. So actually within the network itself, there's 100 domestic buildings and 30 university buildings as well. So in essence, 100 homes and 30 university buildings. We started off the trial on the 30th of October 2019 after basically building throughout the summer. And I think we started on 1%, and then we basically went incrementally up through the steps, and the highest we've reached is 18%, and that sort of keeps us below, gives us a bit of headroom before we hit that 20%, which clearly we can go no further. We can't go above. So each stage, as we sort of gradually ramp things up, we had to go through combustion checks, governor checks, compound. We also had to check the composition, and that's done by a gas chromatograph and also in the laboratory. And we had to do rhinology tests, and then we had to do network review. Basically, are we seeing a spike in incidents, or are gas operatives being called to site? So we had to go through a very staged process to go through, incrementally go through the different blending levels. And what you can see here is, well, what we found out once we started to actually blend into the network was that the network we were blending into was very peaky, very spiky. So 1 minute you would have like a large boiler system that would be on, and that will close off, then the gas would basically completely drop. And that initially proved a challenge, because clearly the blend level on the network had to absolutely follow the gas demand in the network. And as you can see from this bottom graph here, you can see this is us blending at 14%, and above it you can sort of see the spikiness of the network. And we're actually very impressed about how closely we kept within our blend limit when the gas demand was so spiky. We also had a test facility on site where we looked at boilers. So basically we rigged up 8 gas boilers, 4 onto hydrogen blend and 4 onto just normal network, so with no hydrogen blend in it, just to test their operation. And what we've actually done now is, now we've finished the trial, we've actually sent those back to the manufacturers, and we've asked them to identify which boiler they think has been operating on the hydrogen blend and which boiler's been operating on the natural gas. So it's going to be interesting to see what they come back with. So like I explained, we're pretty much, well, we have finished blending now at Keele University. We're in the process of closing it down basically, and now we're looking to start the public trial. So it's basically handed things over to Northern Gas Networks and up at their Lower Thornley site. They're looking to start blending into, well, just short of 700 properties imminently. So that again is expanding upon that safety case. And just to talk a bit about the safety case, so it's been interesting. So I think the headlines is compelling evidence has been compiled on appliance safety to demonstrate a significant reduction in carbon monoxide production. And there's also evidence base indicates hydrogen blend is slightly safer than natural gas. So whereas our challenge from the HSE has always been to prove that a hydrogen blend is no less safe than natural gas, and what we think we're able to demonstrate is that hydrogen blend is actually safer than natural gases today. A few other headlines, I guess. Appliances. So no safety or performance issues identified across a representative sample of GB appliances. Gas characteristics. We showed that potential leaks of blended gas within buildings will produce practically identical gas concentrations to natural gas. So there's no increased risk of, to safety there. And materials, we've done tensile strength and fracture. And we've showed that there's no discernible differences following soaking. So again, we haven't found a reduction in the performance of materials due to exposure to hydrogen blends. And like I explained before, the QRA, so the quantitative risk assessment that underpins the safety case, due to the reduction in CO risk, overall evidence indicates that a lower risk for hydrogen blends compared to natural gas. So I think that's really positive news. So not only have we been concentrating on the domestic side of things, we're also looking at industry, and we're about to start a program where we're introducing hydrogen blends into a 1.2 megawatt furnace, 7 megawatt steam boiler, and a 55 megawatt, so huge glass furnace up at Pilkington's. And that's basically, we've jumped on the back of BEIS's industrial fuel switching program. that Progressive Energy are running. So again, we're starting to expand the evidence for the safe operation of hydrogen blends by looking at industry. Okay, I think I'm probably running out of time now. Where does this all end up? So I guess this ends up for us with the HyNet project from Cadent's point of view. So we're looking to blend 3 terawatt hours of hydrogen into the gas network up in the northwest. I guess just progress on HyNet. We've just had announced that we've received £72 million worth of funding for the project from government funding from the Industrial Decarbonisation Challenge Fund and also private match funding. So now we're undertaking the FEED and the consenting. Cadent is focused on the hydrogen network, which you can see in the black from the graphic. So that's really coming on now, and like I said, that's fundamentally where we want to start the hydrogen blending story at scale. So I think that's all from me. Yeah, happy to take any questions there maybe.
That's fantastic. Thank you very much indeed, Andy. Another speaker who's got 10 minutes absolutely spot on. I don't know how they do this. It's pretty clever stuff. So any questions? If you want to ask a question, please pop it into the chat box. We can then pick them up from there. The other thing I wanted to say is there was a few issues with slides there, Andy, but what we'll do is make sure that everyone gets a copy of your slides. I think you referred to a graph or two, which I don't think we could all see at the same time. So we will make sure that they are distributed to everyone as well.
Okay.
Not your fault at all. Don't worry at all. That's how these things work. Quick question then, first one really. Or something that's coming here, and I was going to throw in the first question, but what aspects of the project did you find the most challenging? And let's just read it, as you're shortlisted for the Innovation Award, what do you think has been the greatest innovation in the project? So what was the most challenging, and what do you think ticked the box for innovation?
I knew the HSE's assessment would be robust of our safety case, but I hadn't quite appreciated quite how robust. So I'd say that was certainly a challenge, and I'd say it went to the extent where absolutely no stone was left unturned, basically, and the amount of evidence we had to provide to satisfy that they were completely okay, basically, to say yes, you can inject hydrogen into Keel's network. I would say, not that we ever did underestimate it, but it was vast. It was huge. It was a massive undertaking. So I think the biggest success of the project would be that from a personal point of view, but also I guess just add in another one would be the consumers on site and how supportive they were of the project. And to be honest with you, the fact that the HSE were involved and they were giving us, making sure we went to absolutely the nth degree to prove that it was absolutely safe meant that they were generally happy to be part of the project. And so I'd say to an extent almost, to be proud of being part of the project.
Did you need to win them over?
I guess.
Did you need to win them over? Was there a lot of skepticism to start with in terms of
far
the
less
with the
than I expected?
Houses?
Yeah, far less than I expected. To be honest with you, I expected it to be, to have to do a lot more. But I think, when they realised who was involved with the project and the due diligence involved with ensuring it was safe, then they were generally supportive. So having that independent HSE sign off was very important. I don't know if we were just to say, no, this hasn't been signed off by anyone but Cadent, for example, or I'm sure it might be different. But having that independent, trusted auditor helped a lot. And
finally, in terms of blending, is blending got a future of its own, or is it a means to an end for a full hydrogen network, do you think? How will that play out going forward?
I mean, it's clearly got a shelf life because it's not going to get you to net zero. I mean, sorry, when I say it's in itself, it's not going to get you to net zero. So it is a stepping stone to net zero.
Yeah.
So yeah, we can't you know, we can't say here we can do hydrogen blending, this is it. You know, we need to go that next step. But I think hydrogen blends across the country is a meaningful first step.
Brilliant. I don't think we've got any more questions, so I'm going to say thank you very much indeed for your time, your 10 minutes, and the questions as well. So thank you, Andy. And I think we've got James to follow on. I can see your name there, James. Can you hear us?
I can hear you fine. Can you hear me?
Yep. Can't see you, but that's fine. We can.
I'm just having some issues sharing video at the moment, but that's probably not a bad thing. So
don't
I'll
worry.
try
Well, I was going to introduce you first, so hold on for 2 seconds. But then I said I was going to introduce you, but then I don't have a lot to introduce you with because I've got a list of bits and pieces about the project, but not about yourself. So all I know is that you're James Hatt, you're Head of Operational Change at Morrison Energy Services, and this is the virtual trial hole assistant. Interestingly, the one thing we'll just throw at you, Morrison Energy Services, I noticed recent name change from Morrison Utility Services. It's interesting that that change of name, it actually shows quite a lot of intent on the company, I would say. So it's certainly something in terms of putting the company right up there. And welcome to the Innovation Awards. And without any more ado, I shall pass over to you to tell us about your project.
Thank you. Yeah, I shall try and share my slides, and please do let me know if they pop up on screen.
There they are. Yep. Carry on.
Perfect. Okay, I'm going to do it the old-fashioned way just to avoid any more technical challenges. So yeah, thanks. Virtual Trial Hole Assistant was led by operations. It was an interesting innovation that was based on some challenge statements work we did. So we went out to operations and discussed what was the most frequent challenges they was experiencing in conjunction with the work we was delivering then as part of our GDSP contract with Cadent across east of England and London. And this will most certainly be carried on into our new arrangement with Cadent through the CMO, or Contract Management Organisation, on the London network. So very much a collaborative project. The challenge was that around 10% of our works each year was aborted, deferred or delayed, primarily because of the asset records. They wasn't reflecting truly what our guys were finding on site, and that's probably no surprise to anyone that's worked in the operational environment. And that had a massive impact on, you know, our resource and planning. And of course, at the same time, we was getting our key stakeholders, the local authorities, which, believe it or not, there's actually 40 of across the London network alone, saying, you know, we've got to be more proactive. We've got to plan better and just react to the environment in which we're working. And getting that planning piece right is becoming increasingly more of a focus alongside some of the technical challenges we had. So we was looking for something that was lightweight in terms of investment, something that Morrison Energy Services could just do. So it was a self-funded innovation. We wanted something that truly reflected the challenge that we was getting back through the operational teams. So we partnered with a company called One Network. You may recognise One Network. They was formerly ELGIN, which was the Electronic Local Government Information Network. So they process all of the permit and noticing data, which is the information that we have to give to the local authorities to get consent to start works in the highway. And they manage this Google Map style interface you're seeing on the screen now. So what we did is we simply took the map of all Cadent's assets in the form of an Esri shapefile, that's the platform they use, and we overlaid it onto this Google Map style template. Now, we picked a very strategic area. This is Southend-on-Sea, which happens to be where I live, and also John Scrivener, the design manager for the London network. And what it basically did was give us an area that we truly understood because we lived there, and also gave us the opportunity to pop out and validate what we believe this product could do. So the idea of this product is that once we've overlaid the Esri shapefile onto the Google Style Maps template, that each time a third party or another statutory undertaker, in this case electronic power and water companies, dig on top of an asset that we've yet to replace, we can physically interact with that company and go out on site and look down that excavation. So when they are working on top of an asset that we're yet to replace, we can go out and basically look down their excavation, look down their hole, and validate, in many cases, our assets, depth, location, so on and so forth. So the great thing about this product is you can filter it by view. Now, in this instance, I was actually looking at the whole of what was the GDSP network then, and you can see in the bottom right-hand corner, there was 1,776 opportunities to go and look down an excavation on top of a pipe we'd yet to replace across the whole of east of England and London, which actually went on to present us a lovely new challenge: is how do we optimize such a big opportunity? Those little dots you can see on this map do represent other parties' notice and permit. So what does that actually look like in ops? Well, when you take a more detailed look, and hopefully you can all see the picture on the right hand side, which is a screenshot, and you can see little taps and flames and so on and so forth. The little taps represent works that's being carried out by the water companies. The flames represent works being carried out by the power companies, so on and so forth. And what you also get is a little pop out, which gives you a very detailed description in many cases of what that other undertaker is doing. So you can make a good assessment whether they are likely to have exposed your assets. So major works, road crossings, etc. And in this case, you can see they're excavating in carriageway over a critical leaking trunk main, which is a water term. But once we know that, and we've got some certainty that our asset will be revealed to us, then that's when we ask our local representatives and surveyors to go out on site, physically look down the hole. And the picture you can see here in the bottom left-hand corner was exactly that. It's where we'd gone out and looked down someone else's hole, and we could see our asset in there, and it was a different size, depth, material, and diameter to what was shown on the construction plans, on the as-laid plans. So, we're getting this type of evidence, which informs our DR4 process, which is our variations to plan process. And also it helps us plan far more accurately, because the traffic management requirements and the the permit requirements are very specific now. So it's really helped us be more focused in our planning, and will continue to do so in the London network going forward. And you can imagine the cost of a trial hole now, when you factor in traffic management costs, permit costs, the time in negotiating with local authorities. Each one of these, it gives us an opportunity to see our asset ahead of our works, and potentially do some more evasive surveying work. Just pays dividends. It's been a fabulous solution. What I would say as well is that we've also used it in some of the planning applications. So as part of my role in Morrison Energy Services, I've actually been mobilising the CMO arrangement with Cadent for GD2, which is the latest contract with those guys. And what we have noticed is that even in the planning process, this product, this platform has helped us identify where there's been Section 58s, which would have precluded our work being planned, which are not always visible immediately through the local authority, but also where there's existing works. I mean, sometimes, as you can appreciate, our colleagues that work in the emergency response and repair process across gas, water and power don't have the luxury to collaborate and share the insight with us of where they're going to be working in advance, because of course it's reactive by nature. So this platform serves that information up to us in real time. We can go out and obviously utilise those excavations, as well as those that are in a planned and controlled way through the normal process. So the scale of the opportunity here is huge, and to filter that opportunity down, we've developed a platform, so it's by screen view. So if you're a project manager and you're responsible for the borough of Southend-on-Sea, for example, you can select to only view what's going on in your borough. So in terms of prioritising how you go out and optimise the opportunity, it just makes it so much more focused. And obviously, massive environmental benefits of the reduced excavation. Enabling, we know, is key to reducing that lost meterage, that 10 to 15% of all deferred works that we spoke about. So having ones that are being done by definition by other undertakers is an absolute gift. It's working really well. And one of the learning items that was did make me laugh is one of the operational guys described that if you gave this platform to someone who could tell you what colour crayon tastes best, it probably wouldn't get the most out of it. And I interpreted that as you need the right people using these platforms. So in terms of making sure you've got someone that truly understands what's happening out there on the network, just helping those project managers understand how to optimize this is absolutely priceless. And also, we're going to rename the innovation because virtual trial hole is actually largely associated with ground penetrating radar. So just to make the determination, we are going to rename it. We're not sure on a catchy name yet. I put it out there to ops again, and I had comments come back like, Boating McBowface and lookinmyhole.com. So, which for interest has already been taken by a paralleled industry. So I wouldn't suggest that we've come up with the right catchy name for this product yet, but I feel that we're going to rename it. So watch out for that soon and the expansion of its functionalities. Just moving on to some benefits before I wrap up. Obviously, reduced excavations, I think we've covered that. The asset verification process through the DR4. The safety case was one that we considered but didn't truly recognise its benefits because, of course, it's not just our records that are sketchy at times in the gas sector. It's also true of power and water companies. So we've been able to understand the depth of third-party plant and the ground type, which has been huge too. The customer impact, obviously, planning more concisely means less disruption. The smarter planning piece has been recognised through our CDM efforts and through the design team in Cadent. And also happy stakeholders. Barry Lucas, that I showed at the beginning of the slideshow, said, this is one of the most tangible uses of technology they've seen for coordination and planning. And it really has taken a load off them. And I was in a meeting with the Greater London Authority this week, and through this platform in real time, I was able to look at what was going on and some works associated with HS2 and some of our other contracts. It's incredibly powerful. So that wraps me up. Hopefully I've made good time there for everyone's benefit. And if there is any questions, please let me know.
That's great. Thank you very much indeed, James. That's very interesting. I've got a question for you to start it off. If anyone else has, please post away. You said about the one dot network where it highlights where there's other companies digging, and that could be on top of your plant. But when you get there, how accurate is that in terms of dead on the plant? I mean, if it's missing by 3 or 4 feet or a meter or two, you're not going to get the information you want. Is that an issue?
It can be an issue. I think the focus is, again, looking at the information in those pop-ups, because what we have to populate in the permits now is incredibly accurate. So, for example, we have to say, what side of the road we're working outside number 1 to 68, for example. So we can determine whether, where they're excavating is on the right side of the road. And of course, for some of the major works, as we identified in that Thames Water job earlier in the city, they was crossing the entire carriageway and had a 3-metre wide excavation for the works on that trunk main. They had every conceivable asset exposed in that area. So yes, there is some challenges, but again, it's about that little bit of work, a little bit of kind of almost pre-enabling, using the platform to its full scope, prioritising it and making the most of the opportunity where you feel there is the most risk. So for example, if it's an excavation on the TfL's network, where permitry and noticing and trying to get road space is incredibly challenging, this is where this type of thing plays dividends. But also in those areas where you absolutely know plants clustered together. I mean, as you know, typically the water main was laid a couple of 100 mil deeper than the gas main, virtually side by side. So there's many occasions where this works really, really well. I would say 80% of the time we're getting a good degree of accuracy. I'm sorry, Dennis, I can't hear you.
That's because I'm muted. I knew I'd get it wrong somewhere down the line. You mentioned there were 1776 occasions on that one piece in Southend, but how do you said about the challenge of prioritizing? I didn't quite pick up how you did that. I mean, you can't send somebody to every one of those 1776. How is it you can get what you want from that information?
Yeah, so that was across the whole of the GDSP's geography, which was East of England and London network, that number. Right. So the first thing we did is we developed with Cadent a structure where each project manager manages a local authority borough. So first it was about putting the right resource in place to really lead a local network where people had local knowledge. We've recognised the benefits of that. And then secondly, we started to prioritise the work stack. So when we planned our quarters for the CMO, we made those quarters visible as a priority. So we set up alerts for that quarter's work, for example. So it really focused them on the following quarter's work. So it really focused them on when they was planning, where are they going to get the biggest bang for their buck? Where can they advance their localized strategies the most based on the data they can get from those excavations? So there's a whole process packed behind this, which in the interest of time I didn't share, but I'm happy to talk anyone through it that's remotely interested.
That's fine. I think if people, obviously we've got your details. If anyone's got any more questions, they can get in touch with you at any time. And like I said, for all the other presenters, the slides will be shared, so that may provoke a few other questions. And once we share the slides, obviously your details there as well. So don't expect not to hear from anyone. I think it was a really interesting project. Now that brings us to the end of those. I will just actually, there was one comment on there which you can see from Simon, who just commented to James, nice to see such collaborative innovation. So congratulations on that. And I think that applies to all of our presenters we've heard from today. We've heard some good stuff from Jeff, Andy and James on what's going on. Collaboration is very high on the agenda, which is really what makes innovation work to its uppermost. I think if you collaborate on that, you get the best of all worlds. So that brings us to the end of today's session. I'd like to thank our sponsors, which is my company SGN, but above all, I'd like to thank our speakers, Jeff, Andy and James, but also a thank you to IGEM operators behind the scenes who have set all this up, who've worked so hard to make it all happen. Linda and Simon, and Simon's even on his day off, he's operating everything from behind the scenes. So thank you both, Linda and Simon, for putting this together and enabling us to come and join the session today. A quick reminder, the next webinar session is next Tuesday, if you wanted to tune into that. But the big event, the one not to miss, is the actual awards. We've waited a long time. We've waited since early 2020 for this one, but they're taking place on the 18th of May. So make sure you get yourself registered, find out who has actually won these, not just the innovation awards, but all the other awards on that day. So please get yourself registered, come and join in. It's going to be great. Thank you.